One very practical application of calculus is work done by a variable force. Suppose I have a force that's being applied to an object, and that force is changing somehow. Now, let me just look at what the change in work would be over some incremental distance. Well, if I can assume that the force is constant for that tiny little approximation of delta x, then the incremental amount of work done is going to be the force at my initial c sub I times delta x, where c sub I could be right end point, or anywhere in between. So I know that the work is approximately going to equal the sum of the incremental works, and plugging in FCI delta x, I get that the work is equal to the sum as I goes from 1 to n, evaluated at some c sub I delta x sub I. If I take the partition as the limit of this partition goes to 0, I get the integral from a to b of f of x dx. As it turns out, that is how we define work done by a variable force moving the object from x equals a to x equals b. Now, here are a list of forces that you simply need to be familiar with. You need to be familiar with Hooke's law. K is a constant of the spring, and you usually have to find it. D is the distance of compression or expansion. Newton's law of universal gravity. This K is 6.67 times 10 to the negative 8 cubic centimeters per gram second squared. And the good news is I will give it to you. M's are the masses, and we're going to measure those in grams. And D is the distance measured in centimeters. Coulomb's law is very similar to Newton's universal law of gravity, except K in this case is equal to 1. We won't get into the units. And the Q's are charges given in coulombs, and D is the distance. Now, the hardest thing about this is figuring out delta W. Sometimes delta W is going to be the force times the distance increment. And this one's not such a challenge. This is constant force when you're changing delta x. So here the work will be the integral from a to b of f dx, which is just f times b minus a. This is a constant force. But what do you do when the force is variable? You're going to need to write delta f in terms of x, all right? So you're going to wind up rewriting it so there's some delta x in there. And you're going to need to use one of the known physics formulas to do so.